Hello everyone. Let's wait for one more minute and we can start the lesson 2 this time. Also let me know, can you hear me well? Can you see things properly? Is the quality good? Okay, nice. You don't see me, and only if you really want to, only then I will show myself. But for now I think a face is a distraction. All right. I think we can start. Yeah. So, Git, the big thing that everyone is using. And today we will try to learn how to use Git. We'll learn what it is. We will learn some theory, but most importantly, we will learn how to use it in practice with Visual Studio 2019 Community Edition. And of course, we'll also learn what is open source and how to work with open source projects. So the agenda. What is Git? GitHub. We'll talk about basic Git commands, the Git flow, merge conflicts, how do we solve them. We'll talk about forking or how do you work with open source. We'll talk about how do you fix your mistakes if you messed something up. What do you need to do to revert the changes that you made, to do undo, and some examples of when Git in Visual Studio is not enough and when you need to pull out console. And lastly, automation stuff. So automated code reviews and automated tests. I'm introducing Git so early on in the course because it would be impossible to track your homeworks otherwise. There's so many people and we need to somehow check everyone's homeworks in a consistent way. And the only way to do that is through Git and automated stuff and with organized stuff, with pull requests. About that a bit later. So let's get started. So Git is a code version control system. And what that means is that it basically tracks history of your code, changes in your code, versions of your code, and you can simultaneously work on multiple features without ever having to conflict with multiple changes happening at once. Code version control systems are based on work that can happen simultaneously, and it's really easy to manage. And pretty much all projects, I would say, if they're any serious, they will be using some version control. Version control doesn't necessarily mean that you have multiple versions of your program. It simply means that you don't have a local copy of your code and you don't copy paste it every single time somebody needs to work on it. It means that you have a single point where your code can be accessed and all the changes, all the history for all the files that have ever changed, it's there in version control. And this system, Git specifically, has been created by Linus Torvalds in 2005. And a little funny fact, Linus Torvalds claims to have created Git in 2 weeks. And it's amazing. GitHub should not be mixed with Git. GitHub is a host for Git. So GitHub is basically a place with big emphasis on open source. So most of the open source projects is can be found on GitHub. And if we compare Git to other version control systems, you can see that it's significantly more popular than its competitors. And this is, of course, an inaccurate statistics because it's simply just questions on Stack Overflow. But I mean, this just shows the popularity and attention that Git has. So you can see that it's roughly 80% of the whole version control empire. So Git rocks, and it's very important to learn it. You don't have to chat in BC discussion. I think chat is good enough. All right, next. So in Git, we have 3 areas, and the whole Git is basically how files move from those areas back and forth. Basically, all the commands in Git can be explained by explaining how the files move from one area to another. So we have 3 areas, and they are working directory, staging area, and repository. So working directory is basically your local work that you're doing like right now. So for example, this guy is digging for treasure. That's his local work. Now, when he dug a treasure and put some coins in it, he did some work, and well, he wants to send it to a pirate ship. And that's and he needs to add something to a treasure chest, and basically the contents of that treasure chest is the staging area. So those are the changes, the files that are ready to be committed. And finally, when you do the commit, you deliver them to a repository, and consider a repository as a vault, some place where code is can be secured. So here is an example. So for example, you start with a full vault of money, and you copy, so repository has 2 parts, local and remote. And here you can see illustration how a typical flow would be. You start with a full vault, and you copy it to your own local environment. So this is a remote repository, and this is your local repository, and this is exactly the same as the original. And then you made changes, so now it's different. For example, you deleted all the files, you stole all the gold from the vault, so now the vault is empty. So this is your local vault now, which has been changed, and you need to push to it to make remote as well to be the same as the working directory. So Hero Tawny asked, so staging area chest gets dumped to vault. Yes, that's true. When you say, well, I'll show. When you say git commit, chest gets dumped to vault. So clone. Clone is the first thing you will do when starting to work with repository. Well, one of the first things. It literally means that you take a remote repository and it becomes your local repository with exactly same state as it was originally. So your remote state becomes your local state with the exact same files. And now, how do files move in terms of git commands? When you do git add and dot means that you add all the files. So git add dot will move files from your local working area to staging area to be ready for commit delivery to repository. So the files that you can add are only the files that have been created, deleted, renamed, or modified. So, edited, I mean. So git add dot will move all the files from working area to staging area. And when files are in staging area, they can now be moved to local repository. So git commit with a message, for example, lesson 2, will move the files from staging area to local repository. And when you are in local repository, then you can work with all sorts of Git features. You can start branching, you can start going back and forth in versions of your code and history. You can have history, and that's why it's best practice to just commit early and often so that you have options to come back to previous places and to go back and forth in history. For example, if you are working on a very complex feature and you did a little bit of work that works, commit. And then even if you went completely off the rails and did some nonsense, you can come back to the point where everything was working fine because it will be marked by your commit. So it's really easy and convenient to do that. And as I said, git commit -m and then a message for commit is all you have to do. Push basically puts files from local repository to remote repository. So you save a file. By saving a file, you mean git commit. So if I do git commit, the file ends up to repository, and then the file is available anytime locally. If I do git push, that file will become available anytime remotely. Even if I move on forward, even if I eventually delete the file, I can still see and use it through history in some way. So it's never gone. Yes, git commit is putting files to local repository. Git push will move them to remote. And now, how do you get files from remote to local repository? You use fetch and pull commands. Fetch command is a more simple one. It will basically get all the files from remote repository to local repository as is, and it won't do anything. However, if you do pull, it will also try to merge the files. So fetch is one command, pull is two commands. Pull is actually fetch and merge. We'll talk about merge a bit later. Now, what do we do if we're working on a feature and we're suddenly interrupted? Like, we suddenly have something better to do, and we need to stop our work and do something else with the same code. What do we do? And the answer is stash. We can stash our work for later. So stash is like a to-do area where you basically put files on a stack. Just files as is on a stack. And you can reach those files whenever you want. They're safe. But the thing is, you have a single stash per all the branches. And it's local. It's only local to your repository. It will not exist in remote. So stash is completely for your local work that you put for later. So if you want to put away work that is not a priority right now, git stash is the way to go. And if you want to return files from the stash, you do you pop files from the stash. Now let's talk about branching. Branching is literally splitting, not splitting, but creating a clone of your existing version of code. And after that, you can work separately on another version of code. So with branches enables us simultaneously working on different features of the same code base without having the need of conflicting and like coordinating too much of work. Because if you work separately, you can do it by yourself. So branch basically copy pastes your repository and making a new branch exactly like the original. And when you work on a new branch, you will have status unrelated to the old one. And yes, a remote repository is shared. Let's continue. Features, bugs, releases, etc. That's basically Git flow. Git flow is a way you organize your branches. You have different categories for branches, and branch has a name. So a branch category could be something like feature, hotfix, release, and a point of interest here is that branch categories like /feature, /hotfix, /release will appear as if they were a folder. So that's a full branch. A full branch name will be /feature login screen. But you will see the branch name login screen in a folder feature as if it was a file. So it's quite cool to for Git UI tools to display it like that. It's very visual, very easy to understand where stuff is and how it works. So what's the difference between a release and master file? Well, the thing is, we don't talk about files. All that you see here is a branch. It's branches. So a release and master branch are two different things because master branch is your base branch. Basically the branch that is currently stable and all the features end up to it eventually. However, release branches are branches that will exist multiple times. Like you see, release version 0.1, 0.2, 1.0. So your release branches can have multiple branching away from the master. So when you create a release branch, you will create a new branch from a stable master. When you have enough features to consider it to be a new version, you will create a new branch from master. And that will indicate a release. Yeah. I hope that answered your question. So to continue, don't work on a master branch directly. That's a very bad practice because people will constantly touch master branch. They will take stuff from it. They will clone it. They will fork it. They will branch it, but they will not commit or push to it directly. How do you integrate changes to a branch then? And that is done through merging. Through merging and or creating a pull request. And merging is literally what it says. You take two branches and they merge content from both branches. So all commits, all the history from one branch becomes the history of another branch. And sometimes you can fail a merge, and you know what happens. We all do. Been there. So a merge can fail if after you merged from the source branch and you made changes, and the branch that was the new one and the source branch, they both had changes after the merge, and you cannot and changes on the things that you both worked on, the same things, and this will provoke a merge conflict. And merge conflicts will prevent you from merging before you resolve them. Yes, conflicting changes. So merge conflicts will look something like this in the picture on the right. So you'll have head, and head is the branch you're at, and you will have to in order to solve merge conflicts, you'll have to pick what parts of files you want to keep, what parts of files you want to delete, or customize it in the output file. And an example of this, how it can be done in Visual Studio, is here. So this is how a merge conflict will look like. So for example, imagine if you had console write line with an empty line in master branch, and after you after you merged from master, you instead changed console write line to console write line hello world, and at the same time master branch changed that to console write line to hello. So on one side you have hello world, on the other side you have hello. Which do you keep? Well, you will need to set that manually. And at the bottom you see the result, which can be edited in Visual Studio just as normal text. And if you click the button here, accept merge, it will, instead of those left or right sides, will keep the bottom side. So that's the merge result. Now, of course, we make mistakes and we need somehow to undo them. How do we do that? And the first, most simple way how we undo mistakes, the most simple ones, is how do we do our commits? How do we change what we want to commit? How do we change messages that we committed with? And the answer is using amend command. You don't have to memorize it, to be honest, because it's quite simple from Visual Studio, and I'll demonstrate that after the slides presentation. However, you cannot amend a pushed commit. It works locally. Now, if you want to amend changes that are not local, you will use some sort of reset command. And depending on what kind of reset you use, you'll have different outcome. But beware, with reset you can lose all your work. If you don't know what you're doing, reset will or can potentially delete the work that you do. So there are 3 types of resets. And the first one is soft reset, being least harmful. With this, you don't really lose anything other than status of the files that were added. So if you don't want to add, like if you want to remove files from the added files list, you can just use soft reset and it will be clear, like no files will be added. So no files will be in the staging area. Mixed reset is a bit more scary. It's not going to make you lose your files, but it will make you lose your commit messages. If you do mixed reset, so if you made 5 commits locally and you did mixed reset, you will now have 0 commits and no files added. But your changes locally are still there. They remained. So that's mixed reset. When would you want to do that? Well, imagine if you had 4 commits, and in those 4 commits you change just 1 file, and you say, well, it would maybe make more sense to just have 1 commit, so you can just add those 4 files and do a single commit message. And that will result in a single commit message instead of 4 commit messages. And lastly, hard reset. If you are afraid of hard reset, I would recommend not using it, at least for the beginning. And if you do use it only on your head for now. So if you use hard reset on head branch, basically you will lose only your local changes. So what happens? So hard reset moves files from a selected commit, all the files from the selected commit repository. And if you had extra files on your local end, or if there were extra files in the repository, they will all be gone. So hard reset is like a history deletion. You will lose your progress if you do it recklessly. So it undoes changes, and I made a mistake. It's not just local changes. It undoes all changes up to a certain point, up to certain selected commit. I mean, not up to, but when you do hard reset, you need to choose a commit. When you do a reset in general, you need to choose a commit, and everything that goes after the commit will be gone in hard reset. So for example, I'm working on a feature and I made 4 commits. Commit 2 was great, but commit 3 and 4 were completely terrible, messy code. I don't understand what's there anymore, and I want to just go back to a good old nice commit number 2. So I will do a hard reset, and that is kind of okay. But when stuff is already in master branch or in remote repository in general, just be very careful using it. And this should be very rarely used, because we don't really want to lose our progress. Now, code versioning, roughly, I would say 20, 30 years ago, enabled people, completely random people who have no idea who's on the other side of the screen, people who have maybe completely different values and beliefs, but people who are unified by work that they want to do, by ideas that they want to implement. So open source has been enabled by code versioning. So essential part of open source is forking a repository. And let's analyze this picture right there. So somewhere here we have a source branch, a source repository. Let's say this is from 0 to 0 bootcamp repository, my repository. And now a student would like to work on this repository as if it was his own. So what would the student do? He would take a fork and grab a source branch from my repository that he wants to work with and fork that branch to his own repository. So this is, for example, my account. This is, for example, your account. And you can just grab a meatball from my account and put it to your account. Meatball being a branch. So you can grab a branch from my account and you can put it to your account. And that won't make you the owner of the branch, and that won't make me lose my branch, but it will make you to be able to work on my branch, but not directly on it, but on your own version. So forking is very similar to merging. The difference is that when I do a merge, forking is very similar to branching. The difference is that when I do a branch, when I create a new branch, it still remains on the same plate, on the same GitHub repository. But when I do a fork, from this repository, a branch will go and be created to this repository. So that's the difference between branching and forking. Essentially the same, the difference is where a new branch ends up in. Is it clear to everyone? Because this is quite important. And if it's not clear, please ask questions. All right, that's good. So, basically, I haven't seen a GitHub repository that is public and would not allow forking. Yes, it is cloning someone else's work. Yes, exactly, guys. I think you got this right. So, let's say you have a homework branch with a task, and that homework branch exists in C# in Bootcamp repository. And now your task is to do a homework. So you need to fork the homework branch from C# in Bootcamp and put that branch to your own account, to your own repository. And then you do your homework. You do the normal git commit, git add, git push, and so on. And when you're done with your homework, you will need to create something called a pull request. A pull request is basically a request for your changes from forked branch to be integrated into the source branch. So what happens? With pull request, consider pull request just like a tiny organized post. A post that you would put in a blog, for example. So it just has a title and it has a content box. So before you make a pull request, you will need to select from your account a branch that you want to be merged into another branch. So you need to select one branch from your GitHub repository and another branch from another account's repository. One note, you can also make pull requests to the same account as well. So pull request is not specifically only for open source, but it's in general for people who want high quality code, who want to review their work. And I didn't really clarify, why do we need pull requests in general? We could certainly just skip that step and merge it directly, right? But here's the problem. How do we know that code that we are going to accept into our own repository from some random person is good? How do we know that it does what we want it to do? How can we trust them? And the answer is we don't trust them, but code doesn't lie. And in pull requests, we will see code. We'll see changes, and by reviewing those changes, we can either accept or decline the pull request. So here is how a pull request in GitHub would look like. And here is what you will need to do for homework as well. So you have a homework 2 as a pull request title, and you can see a box with content. And at the bottom you can see you can create pull request. On the right you can see you can tag reviewers to a pull request. You can assign a person, owner of that pull request, and you can give it a label, like what category is that pull request for. And yeah, that's pretty much it. That's pull request for you. And the process of checking if pull request is good, if it does what it should, if it meets the standards that the owner has, the process is called code review. For our bootcamp repository specifically, we will have 3 steps that you will need to pass for every pull request anyone makes. And that's automated standards review using Codacy. Then you'll have automated tests using Azure pipelines. And you'll have a human, a person who will do a code review. Now, Roloff asked, how do we know which mentors we can ask for a review? And the answer is you don't ask a mentor for a review. I think in general, we will be tracking all the pull requests, and any of the available mentors will just grab one and see if they can add some comments and approve it or decline it. So please be nice to your mentors, listen to their remarks, and if they gave you remarks, mark them as resolved in the pull request dialog, in the pull request page. Lastly, after all homeworks have been accepted, which is right before the next lesson starts, we will select a single best homework and merge it to the source homework task branch. And yes, you ask by creating a pull request, exactly. If you want to learn more about pull requests, about code reviews, about Git, how to do it in console, here are some useful links. And let's Git add everything we learned. Let's commit it, and let's push and start some practical stuff. Now let's move on to practical part, which is working with Visual Studio to do the full Git flow. So pull request is like asking someone for their work. So pull request is like asking someone to review their work. Yes, to review the changes that you would like to merge into some other branch. Yes, so a better word than join would be merge. Yes, I think it would be a better word, push request, but it sounds derp, but maybe it's just because we are used to it. Anyways, let's get some work done. Right, so what can we do? Let's see. So now I'll try to demonstrate how you can do some Git flow and how do you work with open source projects. So let me open some repository from C#in. I'm not directly an owner there, so I can fork C#in repository as to my own personal repository, because this account is organizational. So now I can fork it to my own. So I can probably even take this actually. And questions. I don't see any question marks, so I presume no questions. Okay. So the first step to fork, you need to click this button. So open a repository that you want to work with, select a branch that you want to fork. In my case, I'd like to fork chapter 1/homework/1 and 2. This is the branch that you guys will have to fork as well. So I select this branch and I hit fork. And then it says, where should we fork it? You select your account and proceed. And then it will take like, it says a few seconds, but that's a lie. It's a small branch, but for bigger ones, it can take up to a minute. So here, if I go back to the place I was before, you can see that we have a really obvious difference now, right? Let me go to repository. So before, I was in this repository, CSIN /C# from 0 to hero. But after the fork, it now appeared in my account /C#in from 0 to hero. So it basically got forked. And now I need to clone this repository. I need to clone it. So in order to clone it, it's very obvious with GitHub. The most important bits that you care about are highlighted, are like colored and really clear. So you need to take this URL after you click clone or download button. And you go to Visual Studio. Oh, static noise. Is it any better? Sorry. Is it any better? Let me know, anyone. Oh, crap. Okay. Okay, good. Sorry about that. Okay, so back to the point. We got a URL, a link to a repository. So we copy it, a link to our forked repository. Then we go to Visual Studio and select Team Explorer. If you don't see a tab called Team Explorer, you go to View Team Explorer. By default, it should be visible. Then the next thing you do is you click this Manage Connections button. You select Clone. You enter a repository name. And since I have it already, well, it discovered that I have it already. So I'll just call it personal. Null. And I hit clone. So now it will take this repository and clone it. So it will take a remote repository and put it to my local working space. And you asked, can I clone only my local version? And the answer is no. I can clone, well, it depends actually. Some people don't allow their own branches to be cloned. But I mean, if files are public, nothing prevents you from just copying them, from downloading them. They are public. The difference between cloning and forking is that when you fork, you no longer work in C#bin, but in your own GitHub. And Chubsman said, my VS says to add an Azure DevOps server in Team Explorer. Yes, mine too, but slightly under that message, you should have a clone button for local Git repositories. So click that one and enter the URL there. Local Git repository should exist, that tab. So expand it and yeah. Good. So now we have a local repository. This one, personal, right? So an exact copy of the one that was in the remote. Except that if we look at branches, we have like, well, we have everything in the remote. So I won't work on master branch. I will work on the homework branch that I want. And if you double click this, it will do git checkout and it will move work from master to this branch. And to know which branch you're working on, it's basically bolded. So if 1 and 2 branch in chapter 1/homework is bolded, that means you're working on it. So I'm working on 1 and 2 branch. Now, let's say our homework is to add a new line called Hello World. So I have 2 lines, Hello World. How do I add both lines to my local repository? Because right now those 2 lines are in working area, local working area directory. So I need to move those to staging. And actually, in Visual Studio, you won't really see the staging bit because you do staging and adding to local, staging and committing at the same time. So I added a single line, Hello World. So I say added another line for Hello World. And I do commit. Now, if I want to see if my changes really are there, I can go to history and you can see here is my history. And if I double click a commit, I can see the file that was changed and the change that happened. You see before there was only 1 line at line 9 with Hello World, and now there are 2 lines. So I think this is clear. It should be quite simple. And if I look in my own branch, the one that I'm working on right now, and if I go to source program CS, there is no second hello world line. And why is that? What do you think? Why don't I see a second hello world line, even though I see it there, it's in history, but it's not there? Exactly, local versus remote. So what do I need to do to make the local change appear in remote? Yes, so it needs to be synced, and it's very literal in Visual Studio. Click Team Explorer, sync, and then you have sync options. So you need to click push to move files from local to remote repository. And exactly, kapow, and it's in your remote now. If I refresh, I can see both lines in the remote now. Yes. So that's those few steps, those actually 2 steps are most of the time what you'll be doing. Make a change, go to changes, commit, enter a message, commit, then go to sync and hit push button. It's as simple as that. Crazy, right? How did you make commits again? I'll repeat. If I make a change, I go to changes. In Team Explorer, I go to changes, enter a commit message, exclamation mark deleted. This is not actually a change, so never mind. So I make a change, it appears here immediately, and right. So won't be typing in command line things to commit and pull, etc. No, though if you want to, you can. We can do everything in Visual Studio, almost everything. At the end of this lesson, I will show the limitations of Visual Studio and when it won't be enough, and when you will need to open Git Bash and do some commands to circumvent the limitations. But overall, it's really just basic UI interactions. Command line is not more complex. I would say it's just something that you need to get used to. It has a learning curve though, because you will need to memorize all the things, and unlike the UI, it won't guide you that much. So I wouldn't recommend to start it with the command line unless you really want to understand the ins and outs of what happens under the graphical user interface for Git. However, for the most advanced features, which are like 1% of the time that you'll need, you won't find in Visual Studio. So either way is fine. And the thing is, the tool you choose, just choose the tool that suits you the most. For me, Visual Studio is the tool for me because I'm comfortable working with it. Let's continue. Okay, so I now made the change and I removed exclamation mark and I committed. What do I need to do to remove such a change? What do I need to do to restore the exclamation mark? What's the easiest way? Using Git. And the answer is the answer is hard reset. So I could go to history and I see this commit. So if, like I said, if I select this commit, all commits after will be gone. So if I do hard reset, and you see reset, delete changes. And if I refresh history, you can see that commit is no longer there. And if I go to my program, you can see the exclamation mark is back. For the shocking factors, I'll zoom in so that everyone can witness that it is indeed back. I know, shocking. Now, if I remove the exclamation mark locally, it's quite easy to return the change. So I can simply right click on the changes tab, folder, the change folder, and click undo changes. That's it. It's done. Now, what else? So if I am working on, I don't know, let's say a programming poem, and I added 3 more lines, but then suddenly I need to work on more serious matters and I would like to put this away for later, and I'll put like to do finish later. What should I do? What should be done to put this change for later use? I don't want this now. Yes. So here is the stash selection, and if I hit stash all, save, yes, you can see it's now gone. And as I mentioned, stash is a stack of changes. And if I want to return them, I can put it as like this. So, quite simple. Now, I don't want this. Also, keep in mind, stash persists throughout all branches. So, if you are working on a different branch and you want to drop your stash, your changes will be gone. Whatever. Well, the thing is, okay, so here's a realistic scenario. I am working on a feature and I stashed all the changes I have, right? And now I say, okay, I will work on a different thing now. So I create a new branch. And really, branching in Visual Studio is as simple as you right click on a branch you want to branch from, and then you say new local branch from, and then you enter chapter 1/homework/ 1 and 2 feature X, because we want to be secretive, and I say create branch. So you see, I just created a new branch. And here is the annoying part. If I do something like console.readline, or sure, readline, and I say, let's say var my name, and I say, okay, let it be, this is a good enough commit. I say, so I read my input, my name, and I say, okay, push, whatever, go to remote. And then I go branches, and then I change my mind. I say, I don't want this read line. So what do I do, guys? If I say I want to undo this read line, what do I do? If I want to undo this, I can press backspace, but what if I want to undo the commit itself from the remote? I would probably want to reset it, right? But here's the thing. If I click changes, I still have my stash here. And if I do reset, delete changes, it's still there. But it might not always be there. So if I pop, it's still there. Okay. Right. So if I pop and if I don't swat me, I'm innocent. Because at work I accidentally dropped my colleague's stash and he was quite pissed by me. Well, he wasn't pissed, but it wasn't nice to just lose your progress, right? You know. So what happened? What happened? How did we lose it? Okay, let's try one more thing. Right, let's commit this and let's branch it. I'll call it test. Let's stash this. Let's say like this. Stash all, pop, stash all. So I stashed. How do we drop a stash? How did I manage to drop a stash by resetting a branch? I don't remember anymore. If I reset this one, I think it will still be relatively nice. Reset, delete, boom. And if I go to my stash, Team Explorer changes, stash, pop. First, let's open the file. Oh, no, 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 I don't want that. Okay. Sync. Sorry, confusion. Pop, and restore staged. Right. I am not like using stash that often, to be honest, and it's hard for me to completely explain everything, but Just be careful doing resets when you have a stash, something in a stash, because your stash might get messed up. That's the conclusion. You stash when you don't want to lose progress. Hard reset messes up with state of files, and it includes stash as well, as far as I know, in some cases. It does in some cases, I think. Okay. Okay. So never mind that. Let's move on. Now we have a merge conflict. It occurred because our stash, we had stuff in stash, and so yes, so we have changes on the left, changes on the right, and result on the bottom. And if I select this, it will select changes this block. If I select this, it will select changes of the right. If I don't want either of those, I can like have changes from both or completely different version, as for example an empty main function. And if when I'm done with merging, I can click accept merge. I don't know why those two are still there. But yeah. It's not better to use commit and next back file from this commit if you want there. I don't understand the question. So I showed how to create a new branch, how to fork, how to work with stash, how to commit and push. I also showed how to create merge conflicts. How to solve merge conflicts. I will illustrate how a merge conflict can happen with a better example, because that one was quite chaotic. So let's say we have those two branches, right? Fresh branches, exactly the same. If I add, or no, if I delete one exclamation mark in this branch and commit, so it's local and it stays there, and if I go to another branch and add an exclamation mark and commit it, so it stays there, so in one branch we have no exclamation marks, in another branch we have 2 exclamation marks. And now if I try to merge from this branch to this branch, it will have a conflict. And also one interesting thing, conflicts sometimes are annoying, and when you don't notice them and accidentally try to build your project, it won't compile because this is invalid syntax. So before you do anything, you need to solve them. And this is obvious. One line has no exclamation marks, another line has 2 exclamation marks. And I click on the file that has conflicts, I hit merge button, and I need to select which of the two I like more. And the answer is I like neither of them, and I'll just delete that line altogether. And if I accept merge, that's the result you'll see. So quite simple. And Git is, Visual Studio is just nice to you, and you can immediately commit the merge. And lastly, push would move what I have locally to remote. So one more thing. Let's push. Okay. I pushed. Now, what if I want to erase history that something happened? Let's say all that happened up to this change I want to erase, but all those are already in the remote. All those are in the remote branch. So what if I do a reset and I'd like to push it, but you see, I reset it, it's local, but there's still commits there. And if I do pull, like the history is still there. What happened? What can I do? If I do this again and then refresh, it's gone. But if I pull, it's there. So if I refresh, it's there. So how do I integrate changes? And this is what you really don't need to remember, but I'll just show what you could do, and the only limitation that I found of Visual Studio myself. So I'm at my repository, I open git bash, and I need to do a command to force push the stuff. So force push will drop the commits that I have. And now if I go again to Team Explorer, you see no more incoming commits and no more history. So I just wanted to mention that Visual Studio is not almighty. And I believe it can be done in command window as well, but the point is you will need to do some command eventually in more complicated cases. But for 99% of the time, Visual Studio is just good enough. So I think I've showed all that you should know, that basically the most common flow, all the steps for the common flow, like 99% of my work in terms of Git is in those steps that I just showed you guys. So do you have any questions? Is there anything unclear? And also, don't worry if you don't understand. I'll try to explain it later as many times as it needs. Right. So yeah, I'll give you some resources to learn later. The video will be recorded. I definitely understand that this is way too much for a beginner to know, but at the same time, I have to admit that without knowing this, we cannot proceed. So you'll have to invest some time and just learn it, because it's quite important, if you want to do the homework. So the questions: what happens to a branch when you fork it and work on something and another person forks it and works on it? Do they merge together? And the answer is they are separate. Two different people forking a branch will result on the same branch appearing on their own GitHub accounts. So all good. So it won't be merged, they each will work on their own version of the same branch. So two different versions, no problem. Okay, so let's do something. Imagine this is homework. So my homework implementation, I just added some lines of code. I do changes, random lines, I say commit, I say sync, I say push. Done. Now it's in remote. Now when it's in remote, I can do something to it. I can now create a pull request. So how do we create a pull request? You see two buttons, but obviously I worked on this branch, so this is the one I care about. So I click this pull request button. And remember the picture, you have a chapter name, a title that you put here. So homework 1 put to remote repository, and gibberish random nonsense is my content. And here I select a repository that belongs to me, here I select to which repository I want to merge the changes, to which repository this pull request will end up at. So I want to select CSN, C# from 0 to hero, because this is where all the pull requests go for homework. And yes, as Starwalker mentioned, it's important to have descriptive pull requests because they won't disappear. Pull requests will always remain here, and you can open them as you go. So it's great to have a big picture of what happens. Actually, not a big picture, but a full picture of what you did. So you should ideally describe all the things you did here in detail enough to have a good understanding of what you did. So, and here under I select from which repository and which branch I want to create a pull request. So I want to create a pull request from my own personal account to organizational account, from homework 1-on-1 to homework 1-on-1. Normally you'll probably be merging the same branches except different accounts. Well, for homework that will be the case. So for homework it will be exactly like here, this is also will be matching, but this bit, it will be, instead of my name, it will be your name. And that will be it. So now I'll add some reviewers. For example, alumni minimum, and assignees myself, labels homework, and I say create pull request. Here you can also see the history of this pull request, and I hit create pull request. Now you see I'm no longer in my own account, and I'm here now. So the key points here, this is the full history of what happened in pull request. In pull request I can add comments, such as this. So you can see description is awful, fix that. Actually, you can reply. It's like a thread, like a mini forum basically. And can you add a remark to my code, alumni? I would appreciate that. Oh crap. So if I go to files change, you can see this little plus, and you can add remarks to a single line or a part of code. And basically you can see, you can understand why I wanted to introduce Git so early, because it's just so nice to do code reviews there. So I can say, what's up with so many write line? And actually I can press this start review button and just go through all the files and mark the file as reviewed here. And so I added a single remark, I finish my review, and I say at the end, done, submit. So you can see a piece of code and my remark. And ideally, after you did a change to fix this remark, so let's fix this remark. I removed all the duplicate lines and just say removed duplicate hello worlds. I save, sync, push, and in the end you say removed duplicate lines. And I can actually see the commit that did that. So after I did the change, I also replied to it before I click resolve. So now that I am done, I can click resolve. Questions? So to be clear, we do not have to choose reviewers for our homework. You don't have to choose reviewers. That's correct. Anyone who can will review your code. Right. Lastly, two things. For the first homework, there will be no tests. From second homework, I'll start having automated tests. I cannot have tests right now because we didn't learn what functions are yet. So I cannot really test anything. But from third homework, you will learn what is a function. And I will be able to write automated tests. Now, oh crap. Key points. I have hooked up your pull requests to be automatically code reviewed with Codacy. And when you click on issues with Codacy, it says it's still reviewing. Maybe I have one that's reviewed. Right, about an hour ago, 2 minutes ago. Well, I see somebody made a pull request, right? And no issues. I am pretty sure there should be some issues. Well, new issues is probably because he just forked it, so doesn't matter much. Let's go to this one. So in my own repository, you'll see code quality. That's called a status badge. A status badge is anything really that is clickable and has visualization on some trait of your repository. So we have a status badge for Azure pipelines and for Codacy. Azure pipelines is automated tests essentially, and code quality, Codacy is automated code reviews. So if I go to my issues, master maybe, yes. So if you go to master branch, remember the one with homework branch, we can see the problems. This is markdown problem, so it doesn't matter much. All issues are markdown related. Okay, so maybe there's just not enough code yet to have a decent review. But anyways, the idea here is that if you click on an issue, it will explain why is this an issue, and sometimes suggest a better, way of doing it. So you can find all the issues here and review them. Okay, so do you guys have any questions? I'm completely ready to answer all of your questions. So are there more pages using the arrows at the bottom? There can be as many issues if you mean Codacy. Yes, so there can be many, but in this case it said only 8. Crap, issues. You see, I cannot go to another page, so it's only 8. Let me show you some more practical example of something that has more code, how it looks like. So you see 32% issues is a pretty bad indicator. And if I click to issues and just C#, you can now see more issues. And if I click on any coding issue, you can see why is this an issue? So what's the problem, example, and what's a better solution? So I hope that Codacy will help you guys learn how to write better code, and it will take some work off the mentors. Do you need to make Codacy account? And the answer is no. When you create a pull request, so let's go back to pull request. when you go to pull request, you'll see this little thing. And this means that Code.sc will try to analyze your code. I am not sure why it's failing, but I'll try to fix it if needed. Maybe it's... I cannot explain why it's failing, but I'll look into it. And this is pipelines, doesn't matter. So for homework, what you had in homework 1, you put it to remote repository through a fork from homework branch and submit a pull request so that we, mentors, can do a code review for it. So that's the homework. Now I'll try to paste the homework. This is the homework. So it's quite easy. It's just Git. Purely Git. And last thing. I'll put it on Discord as well, yes. After the lesson, I'll put it on Discord. So guys, we have 25 minutes. Do you know what that means? 25 minutes till the lesson ends. There is something. No! Kahoot is coming, guys. Kahoot. Hype, 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 hype. Kahoot hype. I want some Kahoot hype. Yes, Q&A. So this is the code. Don't do hentai or you'll be banned. So don't risk it, please. We want to remain decent. Please don't push it. So guys, join. Go to here. Click the link. I did increase the time to minimum 30 seconds and some questions for with a minute of time to think. So from minimum 10 seconds it went to 30. Yes, the dark theme. Maybe. I don't know. Yes. We have 33 viewers and 18 players. I'll wait 2 more minutes before we start. Okay, a think we can start. Is Git a code versioning system? True or false? Two more people are yet to answer. I'm afraid that there's still some problems for someone. One person. Well, it's based on true or false and not colors, so pay attention. And yes, Git is versioning system, code versioning. Stacker is number 1. Well done. To move all files from working directory to staging area, what do you need to do? From working directory to staging area. Commit, add, pull, or push. Commit is not the right answer because it moves files from staging area to local repository. To move files from staging area to repository, you I might have lied though. Do you trust me? Okay. You listen well, guys. That's good. Resho, again, Resho is number 1. Guys, don't let him win again. It's not rigged. Believe me, it's not rigged. To move files from local repository to remote repository, what do you do? So your files travel from local repository to remote repository. Yes. It's not pull because it's the other way around. What is a branch, guys? What is a branch? Yes, it's not a file snapshot because a branch contains many files. So rather than being a file snapshot, it's multiple files within a repository, which is a snapshot. Steve is number 1. Woo! So we have 2 branches, A and B. Branch A has a.cs file, branch B has b.cs file, and we do a merge from A to B. Which of the following is correct? Yes, so this is a bit tricky question for the beginners, I guess, because this requires to think quite more. So the second most popular, both files will end up in A, and that's very close, but we don't merge B to A, we merge A to B, and that's the key point. So those who selected those, either of the two, are very close, but the more correct answer is B. If we merged B to A, then this one would be correct. So close, but not. And this also had 4, so worth a mention. So this bit is wrong, of course, but you probably missed this part. But anyways, it has nothing to do with A being modified or not, because different files exist in different branches. So even if A was modified, it's not conflicting with with a different file. So not bad, not bad. To get and merge all files from remote repository to local repository, so the files travel from remote to local. And not only you need to get, but also merge. Get and merge, not just get. And yes, fetch will only get and pull will do both. Hero Tony, this might not be beginner friendly, but don't mind it too much. If you manage to learn this, you will know how to do all you want in Git. So just slightly more effort and it will be great. It won't take much time to learn, really. Which of the following is not kind of undo for Git? So, which command cannot be used for undo in Git? Or which command does not exist? Or which command was not mentioned? Well, this just proves that the question is really bad. So let me explain what I meant. Which of the following is not a kind of undo? Which of the following is not used to undo anything in Git? So with git amend, I can undo a commit. With git reset soft, I can do a state that was added for files. With git reset hard, I can remove changes, all changes up to a certain point. And with git reset medium, it just doesn't exist. So this command doesn't exist, and that's why it was an answer. Not is the keyword here. But this, I don't know why 4 people only selected this. This was quite obvious. I know I'm an asshole. Steve is number 1. Well done, Steve. Resho is second and he's catching up. Will he win a game that's totally not rigged? Well, we'll find out. What is git stash? We talked so much about it, so you probably know. Well done. It is a place to work on files later. It is as well, but we need... So the other answer would be true, but only if we talk outside of the context of Git. So this was a tricky question because we talk about Git. So stash for Git, not just any stash. So please read the question more closely. You and your friend both work on the same file called program.cs in master. What should you do to minimize conflicts? Yes, so as mentioned, you should both create a new branch so that you avoid clashing changes. And the second answer was either one of you creates a new branch. Well, that would work, but what if there is a third person working on master? So then your friend and that other person will have clashing changes. And as I mentioned, it's just bad practice to be working in master. So the best answer is to just everyone create a new branch. Steve and Resho is really close. When do conflicts happen during merge? So when will a merge fail? So when do conflicts happen during a merge? So I think I made a mistake. I should have gave you 1 minute of time to think, because this is quite some reading and thinking. So this is too little time for this. But why is this a correct answer? So as we did with a write line, so what happened? We created an extra write line in a new branch. So in a new branch, we created an extra write line. And in source branch, we removed one write line. So now we have two same files with two different changes. So which change does version control take? We don't know. And so a merge conflict happens. Now, what about the others? Key point in why is this not correct is because different files are changed. If different files are changed, it will merge just fine, because the changes are not conflicting. And this one, the same file was modified in source before target branch was created. Well, if it was modified before target branch was created, then that means that the change persisted in the new branch as well. So there is no conflict in the first place. And that's why this one is correct. So kudos to those who answered right. And will Resho take the lead? 2 more questions. What is a Git fork? Yes, so like we said, when you fork, you move a branch from an account that doesn't belong to you to your own account. So close. Resho 30 points behind. What do you need to do to integrate changes from forked branch into original branch? as mentioned, for open source and for stuff that doesn't belong for you and for, in general, integrating changes, we work with PRs. And the others are just remote and local work with a repository that belongs to you. And this one with one that doesn't belong to you. Or it could be with the one that does belong to you, but yes. But you cannot make any changes to a repository that does not belong to you unless you make a pull request. And so the winners. Michael Fox, 11 out of 13. Steve, second, 12 out of 13. And the winner is again Resho. PogChamp Resho in the chat. Such a close game. Well done, guys. Also, Hero Tawny, if this is too difficult for you, don't worry. We will guide you through. Just take it easy and don't try to learn everything all at once. All that I said, you don't have to memorize immediately. Just take it easy and slowly and you will get there. So, yes, you're a good student. That's it for today's lesson, guys. So, the homework. Let me officially post it now. Also, the slides. So, the slides are here. And the homework will be here officially now. Great that you do. I don't care much that you see my channels. I have nothing to hide. What I would recommend you is use the slides as a guide material. Don't use it too much of a study material. You can have a general idea of how it works, but you won't learn it from slides. What I would recommend though is to do a homework and do it well. So play around with Visual Studio, how to create new branches, how do you merge branches, how do you clone, how do you fork, how do you undo your changes, how do you commit and push. Practice those things and that will be the best study for you. Okay, I take my words back, alumni. So I do have something to hide, so hold your horses. We all do. Though I use incognito, so it's okay. But I won't show it anyways. That's for another lesson. Yes. So yeah, that's it for today's lesson. You basically now got familiarized with a typical flow that happens in Git, stuff that you do on daily basis. Hero Tawny, don't be frustrated for something like this. this in general, this whole lesson is considered to be a lot to take in. And for example, in university, at least in my university in Lithuania, we were introduced to Git only in like second year studies, which is crazy. And this is a second lesson, not second year. So be proud that you attended the lesson and you will figure it out eventually. Pull request denied, especially from a guy who spammed hentai at the start of the lesson. So if you behave, I might consider, but this time, nope. Yeah, you will work it out. No problem, guys. Thank you all for watching and see you in the next lesson, which will be on Saturday, again, 9 p.m. GMT +2. On Saturday, we will be learning how to do functions, how to split code into tiny functional modules instead of having all in the same main function. And with that lesson, we will introduce you to testing. You won't have to write your own tests, but you will need to write functions so that your tests pass. What do you mean by do a countdown, please? A countdown to the next lesson? I will do a countdown to the next lesson after every lesson, so yeah, no problem. Okay. Okay, this is official. On lesson 3, I will be using dark theme. Period. So thank you all for watching and good night, guys. See you on Saturday.